Hello everyone, myself Rupam Das, Assistant Professor of Asansol Engineering College in Electronics and Communication Engineering Department. Name of the subject is Signals and System. Learning outcomes are at the end of the session, student will be able to understand LTI system and properties of LTI system. Contents are LTI system, commutative property, distributive property, associative property, static and dynamic property, and invertibility property. These are the books starting from Signals and System by Anand Kumar. Second book is Signals and System by Turun Kumar Rawat. Third book is Signals and System by Ramesh Babu. Fourth book is Signals and System by Nagor Kani. First of all, introduction to LTI system. Both continuous time and discrete time system have several basic properties. Out of these several basic properties, two properties named linearity and time invariance play a vital role in the analysis of signals and system. If the system has both the linearity and time invariance properties, then the system is called linear time invariant system. And the characterization of linear time invariant systems are: the following steps may be adopted to find the response of a LTI system using superposition theorem. Number 1, resolve the input function xt in terms of simpler or basic function like impulse function for which response can be easily evaluated. Number 2, determine individuality the response of LTI system for simple input impulse functions. Number 3, using superposition theorem, find the sum of the individual responses which will become the overall response of function xt. Now next is convolution of continuous time system. The convolution of two continuous time systems or signals are x1t and x2t is defined as x3t equal to integration minus infinity to plus infinity x1 lambda x2 t minus lambda d lambda, where x3t is the signal obtained by convolving x1t and x2t, and lambda is the dummy variable used for integration. The convolution relation of equation can be symbolically expressed as x3t equal to x1t convolution of x2t, where the symbol this star indicates the convolution operation. Next is response of LTI continuous time system using convolution. In an LTI continuous time system, the response yt of system for an arbitrary input xt is given by convolution of input xt with impulse response ht of the system, and it is expressed as yt equal to xt convolution ht equal to minus infinity to plus infinity x lambda h of t minus lambda d lambda, where the symbol star represents the convolution operation. Depending on this, we are having mathematical question. First question, obtain the convolution of the two continuous time function given below. Xt is equal to e to the power minus t, ht is equal to 3t square for all values of t. Now we know that continuous time signal, the convolution integral is expressed as yt equal to ht convolution of ht, that is equal to lambda is equal to minus infinity to plus infinity x tau h of t minus tau d tau, where x of tau equal to e to the power minus tau and h of t minus tau equal to 3 multiplied by t minus tau whole square. Now using the first equation, we can write yt is equal to minus integration minus infinity to plus infinity e to the power minus tau square 3 into t minus tau whole square d tau, that is equal to integration minus tau to plus tau e to the power minus tau square 3t square minus 6t tau plus 3 tau square into d tau. Yt is equal to 3t square minus infinity to plus infinity e to the power minus tau square t d tau minus 6t integration minus tau to d tau tau e to the power tau square d tau plus 3 integration minus infinity to plus infinity tau square e to the power minus tau square d square, and finally we got this response for this particular problem. Next, the input signal xt and impulse response ht of a continuous time system are xt equal to e to the power minus 3t ut and ht equal to u of t minus 1. Find the output. So we know that the continuous time system, the output of a convolution integral which is expressed as yt is equal to xt convolution h of tau, that is equal to tau is equal to minus infinity to infinity x of tau h of t minus tau. Now we write down the expression like this: x of tau that is equal to e to the power minus 3 tau into u tau, and h of t minus tau that is equal to u of t minus tau minus 1. Now we are putting this expression in this here, so we can write down yt is equal to minus infinity to infinity e to the power minus 3 tau u of t minus tau minus 1 d tau. And by using this we can write down, we can conclude one operation, that is u of tau is equal to 1 for tau greater than equal to 0, and u of t minus tau minus 1 that is equal to 1 for t minus 1 greater than equal to tau, that is tau less than t minus 1. Now we can write down the expression like this: yt is equal to integration 0 to t minus 1 e to the power minus 3 tau into 1 d tau, that is equal to 0 to t minus tau e to the power minus 3 tau d tau, that is equal to minus 1 by 3 whole into e to the power minus 3 tau 0 to t minus tau, and finally we got this response for this form mathematical question. Next is another question we are having: by using the continuous time convolution integral, find out the response of the system to unit step input signal. Impulse response is given as ht is equal to r by l e to the power minus t r by l into ut. Now from the formula we can write down yt is equal to xt convolution h of t, that is equal to tau is equal to minus infinity to infinity x of tau h of t minus tau d tau. Now we know that x of tau is equal to u of tau, that is equal to 1 for tau greater than equal to 0, and h of t minus tau that is r by l e to the power minus t minus tau r by l u of t minus tau. And using the equation we can write yt is equal to integration 0 to tau 1 r by l e to the power minus t minus tau r by l u of t minus tau d tau. And from that again we can write u of t minus tau that is equal to 1 for t greater than equal to tau for or tau lesser than equal to t. Now put down, we are putting this expression over here, and finally after solution we can write down 1 minus e to the power minus t r by l for t greater than equal to 0. So this is the required output of the system. Another question we are having: determine the convolution of two continuous time function, and it is given as xt is equal to 3 cos 2t for all t, and ht is equal to e to the power minus mod value of t that is equal to e to the power t for t lesser than 0, and e to the power minus t for t greater than equal to 0. We know that the continuous time system, the convolution integral is expressed as yt is equal to xt convolution of ht that is equal to tau is equal to minus infinity to plus infinity x of tau h of t minus tau d tau. And here x of tau that is equal to 3 cos 2 tau for all values of tau, and h of t minus tau that is equal to e to the power t minus tau for t minus tau lesser than 0 for tau greater than t, and e to the power tau minus t that is for t less than tau greater than equal to 0 and or tau less than t. Now we are putting this representation over here, so we can write down yt is equal to tau is equal to minus infinity to plus infinity x of tau h of t minus tau d tau, that is equal to tau is equal to minus infinity to t 3 cos 2 tau e to the power tau minus t d tau plus integration tau is equal to t to infinity 3 cos 2 tau e to the power tau minus t d tau. And finally after solution we can write down 1.2 cos 2t for all values of t. Next we are discussing about the various properties of linear time invariant system. We are having lots of property: commutative, distributive, associative, static, dynamic, invertibility, causality, stability, and unit step response of LTI system. First property is commutative property. According to this property, for continuous time LTI system, the output is given by yt is equal to xt convolution of ht, that is equal to tau is equal to minus infinity to plus infinity x of tau h of t minus tau d tau, and yt is equal to xt into ht, that is equal to tau is equal to minus infinity to plus infinity h of tau x of t minus tau d tau. Now this is the graph pictorial representation where input signal xt is applied to ht, and finally the output signal we are getting yt is equal to xt convolution of ht. The input signal ht is again applied to xt, and finally we are getting the response yt is equal to ht convolution of xt. According to commutative property for discrete time LTI system, the output is given by yn equal to xn convolution of hn, that is equal to k equal to minus infinity to plus infinity xk h of n minus k, or yn equal to hn uh, convolution of xn, that is equal to k equal to minus infinity to plus infinity xk hk x of n minus k, and this is the pictorial representation of discrete domain commutative property for LTI system. Now next is distributive property. The distributive property states that both convolution integral for continuous time LTI system and convolution sum for discrete time LTI system are distributive. For continuous time LTI system, the distributive property is expressed as the output yt equal to xt convolution of h1t plus h2t, and yt is equal to xt convolution h1t plus xt convolution of h2t. Thus, two continuous time LTI system with impulse response h1t and h2t have identical inputs and outputs are added as y1t equal to xt convolution of h1t, y2t that is equal to xt convolution of h2t, and from that finally we can get yt equal to y1t plus y2t, and yt is equal to, we are putting down the value of y1t and y2t, that is xt convolution of h1t plus xt convolution of h2t. This is the block diagram representation where you can see input xt is been applied to h1t, it denotes or generates the output y1t, and xt is again applied to h2t, it denotes or generates the output y2t. Finally it is make a addition, and finally we get the output yt, and this can also be represented as xt is applied to h1t and h2t, and we are getting the result of yt. Next, the discrete domain LTI system, the distributive property for this case is expressed as yt or yn equal to xn convolution of h1n and h2n. It can also be written as yn is equal to xn convolution of h1n plus xn convolution of h2n. It's these two equation block diagram based representation is represented over here, just like our previous case. So that's why I'm not discussing this particular section. Next is associative property for LTI system. According to associative property, both convolution integral for continuous time LTI system and convolution sum for discrete time LTI system are associative. For continuous time LTI system, according to associative property, the output yn yt is equal to xt convolution of h1t convolution of h2t, or it can be written yt is equal to xt convolution of h1t convolution of h2t, or yt that is equal to xt convolution of h1t convolution of h2t. An explanation of associative property can also be written as yt, that is zt convolution of h2t. So from this particular figure we can write down this thing, and this particular zt is equal to xt convolution of h1t. So therefore yt is equal to xt convolution of h1t convolution of h2t, and from the figure we can write yt is equal to xt into ht, and here ht is been written as h1t convolution of h2t. So again we can write down yt is equal to xt convolution of h1t convolution of h2t. This is known as associative property in continuous domain. Similarly, for discrete domain LTI system, according to this associative property, we can write down xn convolution of h1n and h2n, or it can be written xn convolution of h1n convolution of h2n, or it can be written yn is equal to xn convolution of h1n and convolution of h2n. An explanation of associative property can also be written as yn is equal to zn convolution of h2n, zn is equal to xn convolution of h1n, and yn equal to xn convolution of h1n convolution of h2n. So it can be written yn is equal to xn convolution of hn that is equal to h1n into h2n, or it can be written yn equal to xn convolution of h1n convolution of h2n. So whatever the equation we have discussed over here, its graphical or block diagram based representation is shown in this particular figure. Next, static or dynamic LTI system. Static system is also known as memoryless system. A system is known as static if its output at any time depends only on the value of the input at the same time. In particular, a continuous time LTI system is memoryless if its unit impulse response ht is 0 for t not equal to 0. These memoryless LTI systems are characterized by yt is equal to k into xt, where k is a constant, and the impulse response, for this case it can be written ht that is equal to k into del t. If k is equal to 1, then the system is called identity system. Similarly, for discrete time LTI system is memoryless if its unit impulse response hn is 0 for n not equal to 0. The discrete time system is memoryless LTI system, and it is characterized by yn equal to k into xn, where k is a constant, and its unit impulse response has the form of hn is equal to k into del n. If the impulse response of a discrete time LTI system it is not identity or 0 for n not equal to 0, then the system is called dynamic system or system with memory. Last is inverse system. The inverse system is used to recover the input from the response of a system. For a given system, the inverse system exists if distinct inputs of a system leads to the distinct output. The inverse system exists for all LTI system. Consider, for example, consider an amplifier with gain A. When we pass the output of the amplifier through an attenuator with gain 1 by A, then the output of the attenuator will be same as that of input of the amplifier. Therefore, the attenuator with gain 1 by A is an inverse system for the amplifier with gain A. So the inverse system is denoted by h to the power minus 1 if xt is an input and yt is the output of the system. Then yt is the input and xt is the output of the inverse system. Here in this case block diagram, suppose xt is the input, and once it is passing through this a particular system, it generates the output yt. Now if suppose that if I want to take or return back the output from the output to the input, so the procedure is you have to apply this yt to a inverse system where the inversion operation is going on, and once the inversion operation is going on, finally you get the result of input xt. So inverse system, again I'm repeating, inverse system is used to recover the input from the response of the system. If in this case one amplifier application has been considered, if the amplifier, that means its input is going to be amplified to the output section. Now if I want that the original signal coming back to the input, so basically we are dealing with the inverse. So whatever the amplification is going on after inverse system, it's recovered or returned back to the original system. So this is basically the inverse system, and these are the references for your future purpose. Up to this, I am concluding today's session. Thank you.